Beach.
Okay, we have started recording. Hey, Shilpi.
Very good.
Yes, hi. Hello, everyone. Sorry about the technical difficulties if you're joining us for Data Ethics for All Live. We have moved over from Crowdcast to Zoom. The link is in the Crowdcast chat window. Hopefully you are able to join us here at Zoom. Today our session is going to talk all about ethics in AI. How much should we do manual intervention? Should we leave it for automation? How much should humans interfere with it? Whether it's for data, whether it's for modeling, we'll talk a lot more. I want to introduce my co-host. He's the advisor for Data Ethics for All. He's a resident AI Excel ML expert. I always mix this up. I know it's so tongue twister, Howie. For me, I always get this wrong. And he is the VP at Zscaler. Please welcome Howie Shu.
Hey, thank you, Shilpi. So yeah, I'm happy to join the party to discuss the data topic today with Axel. Hey, Axel, we haven't met, but you look like you have a very long, interesting background doing big data and then leveraging hardware. I thought that's a pretty unique background because a lot of the AI machine learning people are just doing the software side only, and then you seem to be doing a little bit touching the hardware. Maybe you can tell us a little bit about what you do in terms of on the data side first.
Sure. I'll try to keep it so that it stays digestible. So what we are doing is we design a processor that is intended to augment the security of your digital existence. And usually when you have a look at how it's done, it's rule-based. So if there is a rule that something is dropped because, let's say, it comes from a known IP address that is known to be an attacker, then that rule will be applied and that traffic is going to be dropped. You can do the same not only for IP addresses, but for TCP, UDP port numbers. So if you see something that is on port 3333, it's pretty much always a mini or a minor, so you know you can drop that. But those are rules, and the rules are not very flexible. So ideally, you run those rules, and then on top of that, you have an infrastructure that allows you to learn what kind of traffic is normal. And then everything that doesn't fulfill these requirements will be tagged as abnormal traffic and can either be immediately dropped, or at least an administrative message can be sent that this looks different. It's something we haven't seen before. So that's where AI comes in, and that's what we are doing in our processor. Now, you can do a lot of AI in software, but it's not really capable of doing that at line rate in real time. So what we've done is we've had a look at how we can build what is called a convolutional neural network. And a CNN is the underlying hardware for the artificial intelligence that we are using in our processor. And that's a fairly, I would say, a fairly lightweight design. So we can build a rather large CNN without taking up too much space in our processor.
That's good. I think, with the Moore's law taping off, one of the directions for the chip to be more and more efficient, or keep, more efficient, keep bringing additional efficiency is actually go vertical, right? Having the hardware to understand the vertical, not just the horizontal instruction set. So getting into cybersecurity or getting into another industry, and then do things vertically right on the hardware can be one direction for the hardware to go. That's actually quite exciting. So so since we're talking about data or data ethics here, what is your point of view in terms of, is AI actually bringing less or more bias, or less and more sort of the ethical issues. Like, what's your point of view on this, mega topic?
Well, I think that's something we all have to ask ourselves and question ourselves, right? I mean, how much are we biased towards and against certain things? Because ultimately, I can tell you, the hardware we are building and all of the AI frameworks that I've ever played with, they're all unbiased, because ultimately the designer of the hardware and software doesn't want bias, because you never know what the unintended consequence of the bias would be, right? So the hardware and the frameworks, I can't guarantee, but I can nearly assert that there is no bias in either of those frameworks. Because again, if there were a bias, you don't know what it might entail in unintended consequences. And that's not something anybody would want to do who created this framework either in software or in hardware, right? So it doesn't make any sense for the designers of the hardware or the software or the frameworks to impart a bias in that system. Now, where bias could come in is, of course, when you create the model and when you create the training data, right? I mean, that's an easy way to impart a bias. And whether that is ethical or not, that is beyond what the hardware and the software and the framework designers do. It is something that whoever trains that system needs to come to grips with. And it may be an intended bias, or it may be an unintended bias, right? I mean, I still remember the first days when training data was provided. And of course, if you've got a dog, well, guess what? You train your AI system on dogs, right? And over time, it will be good enough to detect what dogs are. And we'll say, yeah, that's a dog, that maybe it's not a dog. As you train it, and it will detect all kinds of dogs, right? But of course, in the beginning, it would also say the cow, that's a dog, because it doesn't know that's not a dog, right? So now you have to introduce a bias and say, hey, this could be a dog because it's big enough, it has 4 legs, it has a tail, it has a head, right? But that's a cow or a horse. Conversely, on the other end, you've got, small dogs. Well, it will classify cats as small dogs, right? So now you train it. But that's a bias, because now you introduce a concept of this is species A, this is species B. Here's how you distinguish them, right? And of course, that's an unintended bias, but that's what you do, because ultimately you need to be able to figure out, is it a dog, is it a cat, is it a cow, is it a horse, right? So a bias isn't always a bad thing, because it helps the AI system to be trained to do what it needs to be doing, right? It classifies. An AI system is there to classify. It helps you to classify. That's what it does, right? And if you go even further back, I mean, I still remember the days when everybody said, AI will never fly and a chess master will never be beaten by a computer. Well, guess what? Kasparov was beaten by a computer, right? And so then the next frontier became Go. Oh, you will never have a system beat a Go master. Well, guess what? That happened 2 years ago, right? So AI seemingly is always all this stuff that we haven't yet been able to do that is non-algorithmic, right? And so everybody keeps asking me, what is AI? Well, if I had a nice definition of AI, it would be great. I don't have it, because ultimately I can say certain things that are algorithmic, they're easy to explain, right? But AI on purpose is not algorithmic. You train it. And that means inherently there will be a bias. Whether the bias is good or bad, that's a different story, but that's really not up to the developers of the hardware and the software and the frameworks that allow you to use AI to classify things, right?
Yeah, I think there are a lot of valid points here. I differ on one thing slightly in the AI is not an algorithm, or I think AI is as well. It's just not human come up with it. It's human come up with it together with data come up with it. We derive the algorithm. from the training data we prepared, and also derive from some, logics, because, what model to use, do you even use CNN or not? That's a human thing. So together with the data, and then we come up with the algorithm. But ultimately, it's just yet another way to come up with algorithm. So to me, it's also a rule or heuristics, but it's just that not human mankind can reason about that easily. It's sort of given upon us, after training the data. That's how I look at it.
As I said, I wish there were a unified and unique and correct and generally agreed upon definition of what AI is. And your definition is as good as mine, right? Because there's none. Ask computer scientists, ask 100 of them, and you will get 101 answers as to what AI is. Right?
If I can just jump in here, I think what you're both saying is that what I'm hearing is that there are different ways to introduce biases in AI, whether it's, and some biases may be good, some biases may be intentional, while some other biases may be not so good and maybe they're unintentional. But there are biases that can be introduced at the data level, at how clean the data is. They can be introduced at the modeling level on what model we created the algorithm with. And they can also be used at the training level when a human is actually using that model to train that data and say, this is what I want ultimately, and this is not what I want. In all three different stages, there is possibility of introducing bias, whether good or bad, because there is a little bit of human intervention in each of those. But after that point, when the system does its own thing, when AI takes over to process all of this data based on what, the model we have done, the training that we have done, when that prediction is done, then obviously it is unbiased. The machine is unbiased because that's what the machine is doing, whatever we have asked it to do. Am I on the right lines?
I think you summarize it reasonably well, because ultimately, yes, the underlying hardware and the framework will be unbiased, because at that stage, even if you wanted to, you couldn't introduce a bias. The bias comes from all of the data that is fed into the machine to learn, right? And so
I think, it's very fair to say that the technology is not biased. It's the how you utilize the technology can cause the bias, right? That's very fair. But at the end of the day, we're not talking about, we never look at the technology in isolation. We always look at the technology combining with the human, how we utilize it. So to say that technology is biased or unbiased, I think to me, it's meaningless. It is really the entire shebang, like the end-to-end process. Does that cause bias or not? As much as I feel like, by the way, I'm a strong believer of AI and the machine learning myself, and I think it brings human mankind tremendous good because of the technology. But at the same time, I actually feel the bias associated with this, end-to-end process, not just the horizontal platform, the tool itself. I think the bias is there. Not only there, AI and the machine learning does accelerate bias. The reason being that what is the value of AI machine learning, as Axel, you just mentioned, right? Human can come up with simple rules, but sophisticated rules we cannot come up with. At least the human, maybe you come up with 1 or 2 rules a day. You cannot come up with large quantity of rules. But AI and the machine learning would allow you to actually come up with rules that's super sophisticated at a large scale. So from that point of view, if the rules itself we come up with through this entire process, including the human, the thoughts, and then the data the human prepare, and then the AI technology, it causes a bias. That means that the bias is getting accelerated or being amplified. So I think there is such a danger. I think, how we utilize the technology does create a lot of danger from that point of view. Now, that being said, I'm not saying that because of the danger, it's negative. I think we should look at the technology, what the value brings to the table holistically, rather than just the danger part or not.
I agree. I, in fact, wholeheartedly agree. What I'm saying is twofold, 2 things actually. One is any tool humans have ever developed was put under scrutiny, and any tool any we have developed can be used for good or bad, right?
True.
It really is as simple as that. And then the other thing I want to throw into the discussion here is very simple. We're talking about whether AI could be to benefit of humankind or to demerit, right? Could create a problem. Well, to that, my answer would be, well, we haven't even harnessed the inherent peacefulness or the lack thereof in human intelligence, right? Humans have had wars, right? So why would we assume that if there's something that's intelligent, whether that's a human intelligence or whether it's machine intelligence, whether that's any better or worse than what we've done, right? It really is a very simple matter of fact, right? So let's all make sure that whatever we do is being harnessed to the benefit of humankind, not to the detriment, right? And what I'm saying is, if you are the one to train a system for something, make sure that if you need a bias, document it. If you don't want a bias, figure out how you can eliminate the bias from collecting the data that you use to train the system, right? And ideally have somebody else look over it and say, you know what, do you see anything that would constitute a bias in my data that I collect? I mean, my approach to that is very simple. I would have a fully free running AI system that collects all the information, the good and the bad, right? Think back when you were a kid, or if you have kids, what did your parents tell you? Did they only show you the good parts of the world and only show you the good parts of humankind? Or did they expose you to the good and the bad and the ugly, right? Because ultimately, the broader it is that you have as an input set, the better you know what it is. There's no good without bad and vice versa, right? And so if you train an AI system, my ideal AI system would collect all the data by itself and would then come to conclusions, what it likes and what it doesn't like, right? Because ultimately, if you let the AI system collect all of the data and then make a decision as to what it needs to classify as what, then it will be a whole lot less biased as if you feed it data, because you may or may not be as unbiased as you think, right? Whereas if you let it collect everything that there is, the good and the bad and the ugly, then it will be able to create better rules. It will be able to better classify things than it would as if you pre-select stuff. And so my simple take on it is, let's make sure that we have the hardware and the software, and it's so advanced that it can collect all the data at once, and then it can come to its own conclusion. That would be a much, much better deal, and that would much more likely be less biased than a system that is fed by humans.
Wow.
Yeah, so there is a kind of a valid point here that, you know, you don't want the technology being the bottleneck of just getting all sorts of data in, unbiased data in. I have one philosophical question, you know, since you are doing more the hardware side. As I mentioned earlier, right, you know, the getting hardware AI, more AI aware, more vertical aware is what, you know, one interesting trend. But let me just play the devil's advocate for a second, right? What's wrong with, you know, having kind of a more generic hardware and then putting more software, you know, sophisticated software on top of it, so that you have more simple, and I want to say simple, more uniform hardware, so that you get a scale you want. It's very much like, you know, in the last 20, 30 years, you know, what Intel did for the conventional computing side, right? You know, you sort of, you know, from all sorts of different hardware to, you know, consolidate it into x86. Do you see a valid point here that, you know, horizontal hardware, while not as efficient as the purpose-built hardware, but ultimately, you know, it's scaled economically, and then, you know, software development-wise, it's just better. Just what's your thought on that?
Well, if I look at programmability, and if I need programmability for everything, then yes, a general purpose CPU will do better. But let me give you a little bit of background on, you know, what happens in a CNN, which is the basis for everything you do in inference. Mm-hmm. The basis for inference is what is called a convolutional neural net kernel. And the kernel's smallest size is a 3 by 3 matrix, right? And across these, you in order to compute your likelihood over similarities, you basically have a round robin with 8 multiply and accumulates, and then you add your own value to it with the multiplier, and then you divide that by the sum of the weights, right? So that's mathematically absolutely trivial, and you can do that in integer, right? Now, if you build special hardware and special purpose hardware for it, you can make that very energy efficient. Whereas if you run the same algorithm, which is trivial on an x86, well, you have 8 multiply and accumulates, but they're all nearest neighbor operations, meaning you go to memory 8 times. So you fetch memory. And if you look at anything that Intel has published, multiply and accumulate really costs them no power. I mean, literally, it's picojoules, right? Energy. It costs them in the range of a bunch of picojoules. Now, going to memory is a different story, because now you traverse the CPU cache, the interface to the memory itself, the memory controller, and into the memory. And unfortunately, memory isn't quite as fast as the processor. So now if you don't get the data that you want, your process does a task switch or something. And then when you finally get the memory, when you finally get the data out of memory, you now have to transfer it back. And so SSTL2, which is the underlying technology for connecting processors to memory, we're not talking picojoule here. We are now talking millijoule. So that's a factor of 1,000,000 more, right? So the same reason that GPUs exist today, because ultimately triangulation is mathematically fairly trivial, but triangulation occurs in basically between pixels, right? You need to figure out which object is where. Is there something hidden or something like that? Triangulation is inherently pretty trivial. It is just a matter of memory access. And that's a different pattern that you have in your memory access between a CPU and a GPU, right? And so the same applies to an inference engine. And so it's not that Intel's math unit is bad. It's in fact good. It's very good. Both the integer and the floating point math is very good. It's just the access pattern to memory is going to destroy your energy efficiency, and therefore it's not working well, right? And you have on both sides effectively. You have it both on the side of the inference, and then on the other side, when you need to run matrix multi, because tensor math really is matrix math, right? So you're multiplying a row with a column of 2 matrices. Well, that again is something that doesn't work terribly well on general purpose processors because the caching strategies don't work that way, right? And so again, while Intel's processors have fantastically good floating point units and all that kind of stuff, it's unfortunately all upset by the fact that the memory access pattern doesn't jive with anything that Intel or AMD or ARM, whatever for that matter, same, right, that they put in. So therefore, it doesn't matter how much you optimize the inside of the processor for this fairly trivial math that you're executing. It's the access pattern of stuff inside your memory that you need to run. And so I believe that hardware accelerators for both inference and for the training part will vastly outperform anything you have on x86 and general purpose processor. That's just the way it is, right? Same way that you have GPUs today. And hopefully same way that in the future we have security processors as a separate category, because ultimately that again is yet another type of processor with yet another type of math that doesn't lend itself well for general purpose applications.
Cool. Hey, Shilpi, do you have anything on your side? We're towards the end of the half an hour.
See, this is very interesting. So like Axel is bringing a whole new dimension to ethics in AI. He's talking more from a hardware standpoint. If we have a better processor that is able to handle more data in a faster and more efficient manner, then we'll have better AI processing and more AI ML solutions will be more effective.
Correct. And that again helps with the ethics, because now you've got less bias because you don't have to have humans pre-classify, right?
So let me ask you a question. So with the better hardware, would we be still using all the other things that we talked about for the software portion of it, or will that be different?
Well, the frameworks will be unaffected by it, right? So let's say you've already written hundreds of thousands of lines of stuff for TensorFlow. Well, you're not going to throw that away, right? So that means that whoever builds a new TensorFlow processor will have to run it such that TensorFlow applications can make use of the processor. And you know, that's a level abstraction called API, and application programming interface. But we've been doing that as an industry for over 20 years. So we know how to do something that allows you to reuse your higher level code and then introduce something new under it. So the APIs sort of are an abstraction layer that we put in there so that you can keep reusing your software you've written in the application layer on a different processor, right? And so that's not anything that's novel. It's just you need to be aware of it and you need to make it work.
Yeah, I think not only anything not novel, but also super critical for your success. Because if you have to have the software engineer learn a different framework, different tool set, good luck. It's not going to happen fast enough. You like, right? You have to have have them use their familiar tool and the software, and then hopefully it's just one plugin away. That potentially could accelerate things, development process.
Correct.
I would just like to take a few questions from the participants. We have quite a few live participants. So if you have any questions for Axel or Howie or me, please put them in the chat box and we'll try to answer them. We are almost at the end of our show, but we'll have a few minutes for question and answers. If anyone has any buzzing, burning thoughts. Cool. So Axel, while we are waiting for that, so is your technology for hardware, is it ready? Are you still developing it? Where is it?
So the security parts of the processor, they're about ready. We have in fact frozen the logic design. We're about to tape it out. We are adding the convolutional neural net to it. The CNN itself has been ready for quite a while. It's been finished. I think at this point in time, the discussion shouldn't be whether we reopen the frozen Verilog to put the CNN in, because very simply, we had the hardware ready to go, but the integration into the higher levels, that was not quite done. So that's why at this point in time, we left it out. And so coming back to Howie's point, that's a non-trivial issue to integrate a new processor with APIs that do exist and create a new HAL, a new hardware abstraction layer to make it work with it, right? So that's why at this point in time, while the CNN itself has been ready for quite a while, we haven't integrated that into the product because very simply the software and the HAL and the API was not ready.
Nice, cool. So this was a great discussion. I thought we all learned something new. I didn't know so much about hardware. We always talk about ethics in AI from the software point of view, from the manual input point of view, from the human touch. But this was exciting. What are your thoughts, Howie?
Look, my view has always been AI and machine learning is an interesting, very great tool to bring additional intelligence that a human otherwise couldn't come up with easily or at scale, right? Complex enough rules, sophisticated enough rules. So AI and the machine learning will do that. I think what I'm learning from Axel today is actually because of the hardware, you are going to even accelerate things even more, right? So that's kind of a double acceleration. One is through software, and then the other one through hardware. So I'm all good to see more acceleration of AI and the machine learning. This is where my passion is.
Good.
Yeah, we have questions. Yeah, go ahead.
Yeah, we have two excellent questions. So one is about the APIs that are stable and not all. I agree. So that's of course always an issue, right? You have to make the hardware sufficiently flexible to be able to work with different HALs in between the API and the drivers, of course, and the hardware itself. So if you are really unlucky and you didn't plan on properly, yes, you could end up with hardware that doesn't support an API, right? That would be bad. Well, we thought about what we need to implement for quite a while before we implemented it. And so we're reasonably certain that whatever we develop in our hardware is capable of matching up with an API through a fairly thin hardware abstraction layer. So thanks to Paras for that question. Yes, we would be able to mitigate that because we thought about it in advance and not after the fact, right? So it's always good to think about something in advance and not after the fact. Second question is the analogy between AI and a kid learning. And I totally agree. I mean, it takes 18 years. For some people, it takes even longer to learn to get to a point where they are a grown up, right? Mm-hmm. And being adult means that you can make your own decisions and you stick with them, and then you take responsibility if something didn't go the way you wanted it. And you can always take pride in if things worked out well. So look, I totally agree. 18 years is a long time. We believe that a decent AI system can learn at a vastly accelerated rate over a human, right? So as an example, IBM started out with categorizing all kinds of cancers. And so what they did was they fed a system X-rays of patients that were deemed either precancerous or they already had developed cancer. And the system came back with what you fed us with was not entirely correct. There were a few that you classified as non-cancerogenious that actually were precancerogenious. So the system was already able to figure out better than the expert doctors what a cancer and what a non-cancerogenious X-ray looks like.
I think, there are two things I would add. One is, yes, it takes 18 years for a kid to learn and then, learn a lot of things, right? But here, what Axel is talking about is one particular vertical. I think if we do sufficient focus, we can still go pretty long way. That's one. The other thing is, I think the AI technology itself is evolving very fast, like what Axel is working on the hardware side and also on the software side. Lots of paper, so many paper, right? And it's huge acceleration in terms of the technology in the AI machine learning side. Mm-hmm. So what we are seeing today is not going to be what we are going to see 3 years from now. It's going to be
exactly.
It's going to be very different.
I totally agree. I think, so let me first go back to Nick's question, whether adding bias at a hardware level is a reasonable concern. Well, theoretically you can do that, but then if you've got a bias, you will end up with unintended consequences for the bias. So the machine will ultimately be unusable if you add the bias already in the hardware, because you don't know what kind of training data is affecting its bias and how the training data will affect that bias. So I think that is something that hopefully can be ruled out even by other manufacturers of AI systems, right? So I think that the possibility is there, but the likelihood of it is fairly low. I think it's not feasible to make hardware available that already has a bias in it that nobody will figure out that it is biased. It's theoretically possible, but again, I have a hard time believing that anybody would do it. And on top of that, coming back to Howie's point, Google has used its TensorFlow engine to design a new AI accelerator. So AI is already designing new AI machines. Right?
And then people are using AI to design CPU these days.
Correct.
Yeah.
Correct. That's correct. Okay. What else do we have? Collecting label data for CNN. Supervised training can be challenging. Oh yeah, I agree. I totally agree. I don't know yet how to optimize that. So good question from Arash. I don't have an answer to that. I don't know. I can't tell you. And then we have another one from Josel. Security vulnerabilities. They can introduce bias. Yes, of course, absolutely. Let's say your data collection is not only insecure, but it's unauthenticated. In that case, anybody can add biased data to your data that you initially thought may have been very little biased or unbiased. and all of a sudden you're, down a rat hole you don't want to be down. So yes, if there's a security vulnerability in your system and you can't guarantee that all the data is genuine and all the data that you collected is authenticated, then yes, that can easily create a problem in your BIOS. Right? That's the nature of the beast. Right? So you got to know where the data comes from. Okay, Paras, another one. Okay, well, Paras takes the prize today for to answer 2 questions. Yes, I think he's right. So the question is, as hardware continues to accelerate the depth of CNNs and any kind of other AI and machine learning models, will hardware also be able to help engineers with root cause analysis to help humans determine why AI made a decision? Yes, I think that will be helpful, and ultimately we can even use the AI system to tell people when they made a mistake in their decision-making process, right? So yeah, it would be good. Maybe that even helps us to be a little bit more peaceful in the future. Maybe, who knows? There's always hope, right? So yeah, so Paras, good question, and that I have to hope it does, and I have to hope it does it for humans as well.
I'm glad that people have a lot of high expectation on AI. So that shows a lot of energy. That's good. Good for you, Axel, for your business, and good for me as well, because I'm trying to apply machine learning AI to solve some interesting security problem too. So very good.
Great. Very good.
Thank you everyone for your time. I think, we would love to continue this conversation. I think there's a lot of interest. Maybe we'll have Axel back again for round 2. But thank you everybody for joining us today. Thank you, Howie. Thank you, Axel.
Great. Thanks a lot.
It's a fun discussion.
Thank you, everyone. Have a nice long weekend.
Yes. Take care. Bye.
Bye.
Okay. Bye-bye.
Bye.
Bye-bye.